On a clear evening just a few days ago, humanity once again reached for the stars. The mission, known as Starlink 1027, was another chapter in an unfolding story. A story of connection, a story of ambition. From the historic launch pad at Cape Canaveral, a Falcon 9 rocket pierced the heavens. It carried a precious cargo destined for low Earth orbit. This wasn't a mission to a distant planet or a far-off galaxy. This was a mission for us, right here on Earth. Its purpose was to add another string of pearls to a growing necklace of satellites that is changing how we live and communicate. The cosmos beckons, and we, with our ingenuity, are answering its call, one launch at a time. The primary highlight of this mission was its sheer routine brilliance. Think about that for a moment. Sending rockets into space has become routine. What was once the stuff of dreams, a spectacle that halted nations, is now a regular, almost predictable event. This particular Falcon 9 booster, the workhorse of SpaceX, was on its 15th journey to the edge of space and back. Imagine a ship crossing the ocean not once but 15 times. This reusability is the key. It makes space more accessible, more affordable. The mission successfully deployed 22 new Starlink satellites, each one a tiny, sophisticated node in a vast global network designed to blanket our world in connectivity. How does one send a satellite into space? It begins with a controlled explosion. A rocket, like the Falcon 9, is essentially a tall, sleek can filled with incredibly potent fuel and oxidizer. When these two mix and ignite in the engine chamber, they create a tremendous downward-facing blast of hot gas. This is Newton's third law in its most spectacular form. For every action, there is an equal and opposite reaction. The rocket pushes the gas down, and the gas pushes the rocket up. It's a brute force method, a powerful, calculated shove to escape the relentless pull of Earth's gravity. The journey is a multi-stage affair. A single rocket cannot simply fly all the way into orbit. It's too heavy, so it sheds weight as it goes. The first stage, the largest and most powerful part, does the initial heavy lifting. It burns through its fuel in just a few minutes. Once its job is done, it separates and falls away. In the case of SpaceX, it doesn't just fall. It performs complex maneuvers using its own engines to slow down and steer back to Earth for a soft landing. This reusability is the revolution that has made frequent launches possible. With the first stage gone, the much smaller and lighter second stage ignites its own engine. This stage is the precision instrument. It performs a series of carefully timed burns to push the satellites into their exact, desired orbit. Orbit is not a place, it's a state of motion. It's a continuous high-speed fall around the Earth. The Starlink satellites are released. They drift out into space, each one a compact, flat-panel robot ready to join the constellation. So what is this Starlink system that these satellites are building? Imagine the internet as a physical thing, like a network of roads. In cities, we have superhighways of fiber optic cables buried under the ground. These cables transmit data using pulses of light, moving at the speed of light. But you can't lay these expensive fiber optic roads everywhere. Middle of the ocean, top of a remote mountain, heart of a dense jungle. There are vast regions of our planet left disconnected from this digital highway system. Starlink is a different kind of road network. It places thousands of small satellites in low Earth orbit, just a few hundred miles up. These satellites act as communication towers in the sky. Your home has a small satellite dish that automatically points to the sky, searching for a passing Starlink satellite. It locks on and establishes a connection. The satellite relays your internet traffic between your home and a ground station connected to the global internet. The key is having many satellites very close to Earth. Traditional satellites sit much higher. Starlink satellites are over 60 times closer. That proximity cuts latency, making connections feel snappy like fiber. It's like talking to someone in the next room versus shouting across a vast canyon. Because they're in low orbit, satellites move fast relative to the ground. A single satellite zooms across the sky in minutes. So the system needs a whole constellation. As one satellite moves out of view, your dish hands off the connection to the next satellite coming into view. Think of celestial relay runners passing a data baton. This dense web ensures satellites are always overhead, weaving a blanket of light around the entire globe. Why does this matter? For many of us, fast internet is a utility we take for granted, like water or electricity. We use it to work, learn, shop, and connect with loved ones. But for billions of people around the world, this is a luxury they have never known. Imagine being a student in a rural village. Your school has no access to the vast educational resources available online. Now picture that same village with Starlink. Suddenly the entire digital universe is at your fingertips. That student can now access online courses and their teachers can use new digital tools to create more engaging lessons. A local clinic can now conduct telehealth consultations with specialists in a major hospital, potentially saving lives. A small farmer can check real-time market prices and weather forecasts, allowing them to sell crops at the best time. This isn't just about faster streaming, it's about unlocking human potential on a massive scale. It's about leveling the playing field. Consider first responders after natural disasters. When ground infrastructure is destroyed, a portable Starlink terminal can be deployed in minutes. It allows emergency crews to communicate and help separated families find each other. This technology empowers remote workers. An entrepreneur can run their business from a cabin in the mountains or a boat on the ocean. A scientist can set up a research station in the Arctic and transmit massive data sets in real time. By connecting the unconnected, we are fostering a more resilient, equitable, and interconnected global village. Let's zoom in on the specifics of the Starlink 1027 mission. It took place on September 19, 2025. The launch vehicle was a flight-proven Falcon 9 rocket, specifically, booster B1078. This was the booster's 15th successful launch and landing. The launch occurred from Space Launch Complex 40 at Cape Canaveral Space Force Station, Florida. The instantaneous launch window opened at 8:15 p.m. Eastern. The rocket lifted off precisely on schedule, painting a spectacular arc of fire across the night sky. The payload consisted of 22 second-generation Starlink satellites, often called V2 mini satellites. These V2 minis are more advanced than earlier versions, with more powerful antennas providing 4 times the network capacity. They are equipped with an innovative argon-fueled Hall thruster. Instead of krypton, argon is more abundant and less expensive. These satellites are the building blocks of a more robust network. After liftoff, the first stage burned for roughly 2.5 minutes, then separated from the second stage. The first stage landed precisely on the drone ship, a shortfall of gravitas about 8.5 minutes after launch. The second stage reached parking orbit, then reignited to circularize at roughly 300 kilometers altitude. Deployment of the 22 satellites occurred about 65 minutes into the mission. Once released, they used ion thrusters to climb to their final operational altitude of 530 kilometers. This mission added to Shell 10 of the Starlink constellation, improving coverage over equatorial regions and mid-latitudes. While Starlink is new and exciting, satellites have been silently shaping our modern world for decades. They are the unseen architects of our daily lives. Every time you use a GPS app to navigate, you are having a conversation with a constellation of satellites. The Global Positioning System is a network of about 30 satellites that constantly broadcast timing signals. Your phone calculates tiny differences in signal arrival times to pinpoint your location with remarkable accuracy. This precise timing is the backbone of the global financial system, synchronizing transactions across stock markets worldwide. It enables precision agriculture, where GPS-guided tractors can plant seeds with centimeter-level accuracy, increasing yields while reducing environmental impact. Shipping companies use it to track fleets globally, optimizing routes and ensuring packages arrive on time. The world's interconnected economy literally runs on time, kept by atomic clocks orbiting in space. Satellites are also our planetary watchdogs, providing crucial perspective on Earth's health. Earth observation satellites monitor climate changes, tracking melting polar ice caps, rising sea levels, and greenhouse gas concentrations. They help us forecast weather, giving advance warning of dangerous hurricanes and tornadoes, allowing communities to prepare and evacuate. They monitor Amazon deforestation, detect illegal fishing, and help firefighters track wildfire spread in real time. When you watch live international events or breaking news from distant continents, that signal was likely bounced off a communications satellite. These satellites have been the workhorses of global broadcasting for over half a century. From GPS and weather forecasting to global finance and environmental monitoring, these orbiting machines form invisible infrastructure that underpins our civilization. The Starlink launches are simply the next evolutionary step, extending that infrastructure to provide high-speed data to every person on Earth. The ongoing series of Starlink launches represents more than just internet expansion. It signifies a fundamental shift in our relationship with space and each other. Each successful launch and landing reinforces the new paradigm of reusability, dramatically lowering the cost of accessing orbit. This affordability opens the door for a new generation of scientists, entrepreneurs, and dreamers. Space is becoming less exclusive and more of a common domain for human endeavor. The immediate goal is global connectivity. Bringing reliable internet to forgotten corners plants seeds of opportunity, empowering children with education, connecting patients with doctors, giving small businesses access to global markets. This bridges the digital divide and builds a more inclusive global society. This is a powerful tool for development with the potential to uplift billions. This LEO infrastructure is a stepping stone to grander ambitions. A robust launch system proven through hundreds of flights will be needed for lunar bases and Mars missions. Starlink could extend to provide communications for astronauts on the Moon and Mars. We are building systems to become multi-planetary. Each Starlink launch is a small but crucial step. Look up at the night sky. Sometimes you'll see a train of satellites passing overhead. They are a symbol of human curiosity, a testament to our drive to connect, to explore, to understand our place in the universe. These launches deploy more than hardware. They deploy hope. They write a new future, more connected to each other, and ultimately, to the stars themselves. From a routine launch to a vision of interplanetary civilization, we are writing our future in the stars, one satellite at a time. The cosmos beckons, and humanity, with boundless ingenuity and determination, continues to answer its call.